Hello everyone, and thank you for joining this session. My names are Fonbat Barista Fondi, and today I am happy to present my research, which is on the integrating of SPARQL and LLMs for question answering over scholarly data sources. This research was done together with Dr. Azanzi Jomeko and Professor Kamara Gauso. The research is going to follow this structure, which is we start with the introduction, move to the methodology, we do the data processing, discuss the results, and then we'll finally conclude. For the introduction, I'm going to give you a small background or a short background on what the whole challenge was all about. So the scholarly question answering challenge of 2024 was a hybrid one, which was aimed at answering questions over academic data sources by providing answers to natural language questions based on both structured and unstructured data. This is a structure which shows the various data sets which was given to us and how they were integrated together. There was the DBLP, the SemOpenAlex, and also the Wikipedia text which was provided to us by the organizers. And then two data sets were provided to us, which was the trained data set and the test data set for this challenge. For our contribution, we implemented three different approaches, which was first the SPARQL queries, next the divide and conquer, and finally the LLMs predictions. All of this will be explained in detail during the demo. For enhanced question answering, we use the divide and conquer strategy because the LLMs prediction could not get context for all the questions, and then created the context using the SPARQL queries for LLM predictions. Now the methodology is divided into 4 stages, which we started with the data processing, and then we moved to query execution, then we did the divide and conquer strategy, and then we also did the LLM based prediction. The LLM which we choose here was the BERT-based case squad 2. Now for the data processing, you see here is a structure which shows how we did it. You would see that if you follow the colors on the structure, here is a green color, this is a green link here, and here is a green link. So from the link that we got in the local file, which is SemOpenAlex, this is the link which was the name which was returned from the endpoint. You see it's different from the name in the local file, and then the real name is Simon Patton Jones. Why we got this as the real name is because when you look at this name, you will notice that there is no Wikipedia context found for Sam L. Patton Jones. So that was how we did for the data processing. Now for a divide and conquer approach, what we did is we break this data, the data set, the test data set which was provided to us by the organizers, into questions, author related questions and institution related questions, and also according to the data sources, which is the DBLP and the SemOpenAlex. This was done. You can see this equation at your right. It explains this, which is the various sets. That's the author link, the links which has double authors to the which needed comparison, and then now there was the authors link, there was the institution, the one for H index, I10 index, acronyms, and the rest. Now here is a structure which shows how this breakdown process took place. For the data retrieval, because we break down this data set, it needed that we should combine back this data set in order to get a single file which we are going to use during the refinement phase before our submission to Coda Lab for evaluation. Now how was this done? We did this by creating a CSV file. This CSV file was converted to a JSON file. All of this will be mostly explained during the demo. Now for the large language predictions, the large language model used what we call a context. I created a particular context. This context was used by getting SPARQL queries to access the various knowledge graphs provided to us by the organizers, get context and form what I call a context, and pass this context to the LLM. The LLM will now be able predict answers based on the context. Now here is how the LLM prediction works. First, it takes the test data set which is provided by the organizers and extracts the context. Now for it to extract the context, it's a file which accesses the SemOpenAlex, accesses the Wikipedia tags provided to us by the organizers, and also accesses the DBLP to be able to get this information. It got 402 questions out of 702 questions. The rest of the questions were names which were not coherent or names which were not found in these knowledge graphs. So to resolve this, we needed to use what I call a Wikipedia page content. And now we got the page content for each author, and then pass these two files, now refine them and pass them to the LLM which predicted the answers and saved the prediction in a file known as output 1. Here is an overall methodology of how it's done. Here is that of the LLM which I've already explained. Here now is the divide and conquer strategy which we use. The first thing we did, we took the test data set, we break them down into 3 different data sets, into many different sets. After doing that, while doing that, we generated a CSV file, converted this CSV file into JSON and kept it. Now we came back to the files that we have broken down, added a foreign key to each of these sets. The foreign key here is the name of the answer which is supposed to be gotten from the CSV file. We then compared these keys to the answers which we stored in the JSON file and combined them at the end to give the final prediction. Now the last phase, which was the local prediction. Why we did local predictions was because we noticed that the knowledge graph provided to us by the organizers, which was local, is different, had different information from the ones provided from the ones online. Now the prediction, at the end we took these 3 output files, which is prediction 1, prediction 2 and prediction 3. We passed it to the file known as refinement, and this file refined and created our file which we finally submitted to Codalab. The evaluation was done using F1 score and exact match for accuracy. We noticed that the LLMs and queries, when combined, gave us the highest result which we expected and which we submitted. For the LLMs only, it gave us a result of 0.289 as precision, as F1 score, and the SPARQL queries and the queries only gave us a result of 0.189 as score, and when we combine it, it gave us the 0.4359 as result. Here is the score which we got. Now we are going to move to the demo. So for the conclusion, I'm going to say the integration of SPARQL queries and LLMs improves the accuracy and also the contextual understanding by the LLM also makes robust solution for complex academic questions. Now let me show you a live demo of the program. So now what happens is this: when you get the file, when you pull the repository online, you install the necessary libraries, and after installing the necessary libraries, for you to run it, you just run the command python llm BERT, and when you run it, it's going to start. And what it does is this: it accesses this file, which is the LLM1, the first prediction LLM1, and it creates 2 files here, which is known as answers 2 with context, and then the final prediction. That is what it does. So now what's the difference between these 2 files? This one has just the answers, which is the ID and the answers as requested by the organizers for submission. Why I created this is because I needed to evaluate the LLM's only prediction. And then now this is the file now with the context, which was done by the LLM. So how is this context gotten? To get this context, you go here and you run this file, which is extract context, and this file accesses the test data and gets this link gets the author name from the link, and then based on the question it's going to create a context for these questions and also for this author. Now how is this done? When you access this link, it gets the name, which is, for example, the first link is Pat Morin. Here is Pat Morin, and then now it gets this and it goes to here, it puts Pat Morin, which is the name of this author, searches it, and then this talks about the institution of the authors, because when you look at the question, here, you'll notice that it asks how many citations have the publication of the institution. When you see institution, I mean that it's talking about the author's institution, I mean that you need to access this SemOpenAlex on the author's institution. You copy the author's institution, you come here and you look for the part where it says institution. Now you'll notice that it's going to tell you 1,200,000 and this, and when you come to the answers which was predicted by my result, and you are going to see that it has predicted it correctly. It's the same thing for the next questions. If you continue with this method, you go to the next questions, which is what it asks the cited by count of the author. Now you come here, you are going to get this name, you copy it, and you go now back to the SPARQL query. If you search it here, and then after searching it, it asks for the author cited by counts, and you notice that here's the cited by count here, which is 14,800, and if you come here, you are going to notice that here is the answer which was provided by my LLM from the context which I got. So that's it for the presentation. Thank you for your keen attention. I'll be very glad to receive any questions if there are any. Thank you.